In this question, we are given a sequence n of non-zero numbers and a pair of consecutive terms with opposite signs represent a sign change. For example, we are given a sequence 2, 3, minus 4 and 5. Now, the first two terms are positive, and starting from the second term onto the third term, there is a sign change. And again, when the sign changes from negative to positive, there is another sign change. So, in total, there are two sign changes. Now, we have to find if the sequence of non-zero numbers S1, S2, S3 have an even number of sign changes. So, let's move on to step 2 and analyze the statement 1. According to the statement 1, the sequence Sk is defined as minus 1 to the power k. Then the terms of the sequence will be minus 1, 1, minus 1 and so on till minus 1 to the power k. Here, we don't know the value of k. So, if k, then suppose k is equal to 3, then the terms of Sk will be equal to minus 1, 1 and minus 1. So, the number of sign changes here is 2, which is 1 less than 3. Similarly, if k is even, let's assume the value of k to be equal to 4, then the sequence Sk will be given by minus 1, 1, minus 1 and 1. So, in total, there are 1, 2 and 3 sign changes. Again, this is 1 less than the value of k. But we are getting two different answers in the two cases. Hence, statement 1 is not sufficient, and out of the given options, we eliminate options A and D. We now check the sufficiency of statement 2. Statement 2 tells us that the value of n is odd, but here we have no information about the sequence or the general representation of the sequence. Hence, statement 2 is also not sufficient. And we move on to the last step, which is step 3, and analyze the statements together. According to statement 1, Sk is equal to minus 1 to the power k, and according to statement 2, the value of n is odd. Therefore, Sk will be equal to minus 1, 1, 1 when the value of n is 3, or Sk will be equal to minus 1, 1, minus 1, 1 and minus 1. In both the cases, the number of sign changes is 1 less than the odd number, which will be even. Hence, after combining the two statements, we can conclude that there are even number of sign changes. So, the two statements together are sufficient, and thus the correct answer is option C.